The first is native scroll-driven animations. Like the name implies, this new API enables developers to create scroll-based animations without relying on scroll observers or other heavy scripting. Similar to how time-based animations work on the platform, you can now use a scroller's scroll progress to start, pause, and reverse an animation. So as you scroll forward, you see that the animation progresses, and as you scroll backwards, it'll go the other way around. This lets you create partial or full page visuals with elements animating into and within the viewport, also known as scrollytelling for dynamic visual impact. You can also build more subtle effects, like this animation of images as they enter the viewport. And this can be done with just a few lines of code declaratively in CSS along with the rest of your styles. First, you set up a CSS animation using keyframes like any other animation effect, and then use the animation property to attach it. The differences start here, where instead of setting a time-based duration like 1 second, you set an animation timeline. In this case, we're using the view function with its default values to track the image relative to the scroll port, which in this instance is also the viewport. And we want this to happen from the moment the image is partially in view up to the point where it's in the center of the scroller at 50%. And you can do this by setting the animation range so that the scroll-driven animation only occurs in a segment of the entire view timeline range. You can animate images, elements, text, or really anything in your view as you scroll. And this demo adds a little bit more dimension with a translation as it scales in and the shadows get deeper. One reason I particularly love this technique of animating elements is that it lends itself so nicely to progressive enhancement. This means that unsupported browsers will get the default user experience, while users on supported browsers will see that little bit of enhanced interactivity. You can use a CSS at supports rule to ensure that only developers on supported browsers get this enhanced animation. And you can combine this with a user preference query to ensure that users with preferred reduced motion don't see this higher level of interactivity. Scroll-driven animations can mean full-page scrollytelling experiences, but they can also mean more subtle animations, like a header bar minimizing and showing a shadow as you scroll a web app. This demo is created by making a few different keyframe animations for the header, the text, the nav bar, and the background, and then applying respective scroll-driven animations to each. While they each have a different animation style, each of these get the same animation timeline, the nearest scroller in this case, and the same animation range from the top of the page to 150 pixels. Not only does this native API reduce a code burden that you'd need to maintain, whether that's custom script that you wrote or via an additional third-party dependency, but it also removes the need to ship various scroll observers, meaning some pretty significant performance benefits. And this is because scroll-driven animations work off the main thread when animating properties that can be animated on the compositor, like transforms and opacity, whether you're using the new API directly in CSS or via the JavaScript hooks. Tokopedia recently used scroll-driven animations to enable the product navigation bar to appear as you scrolled. Using the native API has had some serious benefits, both for code management and for performance. Because it eliminated the need for third-party scripting, they were able to reduce the overhead and maintenance for this feature by eliminating 80% of their scroll-driven interactions code. Additionally, the Tokopedia team saw significant performance improvements in CPU utilization, reducing it from 50% to 2% while scrolling. We know these effects will continue to make the web a more engaging place, and we're already thinking about what might come next, including the ability to not just use new animation timelines, but to also use a scroll point to trigger the start of an animation. And you've likely seen effects like this all over the web. We hope to make this a reality as an addition to this powerful feature set in the months to come. And there are even more scroll features coming to browsers in the future. This demo by Adam Argyle shows a combination of these features. CSS scroll start target to set the initial date and time within the pickers, and the JavaScript snap changed event to update the header date, making it trivial to synchronize the data with the snapped event. You can build on this to update a picker in real time with the JavaScript snap changing event like you see here. While these features are only currently available in Canary behind a flag, they unlock capabilities previously impossible or very difficult to build in the platform and highlight the future of scroll-based interactions possibilities. And the tooling for these features has had a nice improvement recently as well. The DevTools Animations panel now supports the ability to inspect scroll-driven animations, see their start times relative to each other and relative to the scroller, and to scrub through the timeline. This visual representation, along with the new, more declarative API, makes working with scroll-driven animations so much easier. To learn more about getting started with scroll-driven animations, our team just launched a new video series that you can find on the Chrome for Developers YouTube channel. Here, you'll learn the basics of scroll-driven animations from Baramas van Dam, who's sitting in the front row here, including how the feature works, vocabulary, various ways to create effects, and how to combine effects to build rich experiences. It's a great video series. I highly recommend that you check it out.